Hi, my name is Kulneet, and I'll be demonstrating some of my test points from Project 1. I'll start off with the condensed nearest neighbors classifier. I basically wrote a script that goes through the entire pipeline. So you'll see it's processing the data set. And the first test point that I'll be talking about is the z-score calculation. As you can see, z-score is calculated by the value x minus the mean over the standard deviation. And as you can see here, this is my approach to the z-score calculation. My distance calculation was the Euclidean distance, which is 0.1 minus 0.2 squared equals the distance value, and then this is taken into the actual distance metric where all of the distances are added together and then square rooted, essentially. And then the next test point is the condensed nearest neighbor points, how they're being added to by my algorithm. So this is an example for the car evaluations data set. There's this point that was marked as good. It was added to the training set due to y equals good being mispredicted, essentially. So as you can see, we have all of our experiments, and then we have our final error. So now I'll be running my k nearest neighbors classifier. And this one is very similar to the condensed one, except for here I will be demonstrating how the k nearest neighbor points are calculated. So you see here, for this particular point x, there are three neighbors, which are these three right here, which are all marked as unacceptable. The true value is unacceptable, which we guessed correctly. So this is showing you how I'm doing the nearest neighbors calculation. Next thing I'll do is I'll show you my null classifier. So the null classifier is essentially the model that just returns the mean value for every single data set. So we are going to be running that. It's really quick. This was ran on the breast cancer data set, and this gave a 66% accuracy. As you can see, this x value was passed in. The model returned 2, which means benign, which is correct. Now we will do the same thing for the basically the null regressor model. This is very similar. For this x value, essentially the model returned 9.92, which is pretty far off from the 2 value that is correct. So this we would consider false. Okay, the next thing I would like to talk about is how we split basically the different data sets. So I'm going to be running the abalone data set, as you can see here. I'm running my split function in my pipeline, which essentially will split it into a training set, which is 40%, the validation set, which is also 40%, and parameter tuning set, which is 20%. This is stratified as well. I just wanted to give you a good look at how this is done. So you see here, this is about basically 20%. The training would be 40, and then this one would also be 40. The next thing I'd like to talk about is the schema. Essentially, basically how I transformed categorical data into ordinal encoding. So I'm going to show that here. Essentially, if you can see over here, this ordinal mapping is enumerated values. In my data structure, they're converted into integers as so, and then they're z-score normalized. I wanted to quickly run the k nearest neighbors regressor to show basically how the kernel function is calculated and an example point that is being regressed. So as you can see here, the Gaussian kernel takes an input distance, squares the distance, uses the gamma, and then takes it to the exponent, and then you get your final kernel value. With the k basically example point, you essentially take all of the features, you put in the model, and you get the calculation, and then the prediction comes. You use your hyperparameterized k and gamma values.